Hello, my name is Ebuka and I'm making this video to actually share my first exciting journey with the CompTIA SecAI Plus. So I wrote this exam today and I passed the CompTIA SecAI Plus exam. This exam has like 54 questions and I wrote in a center in 60 minutes. So I know people might ask, what is the difficulty of this exam? This exam is fairly medium difficulty, and especially for me in the domain of LLM or AI enabled security. First of all, I'm a PhD student and my focus is in large language model security and also the use of LLMs for network security. So I found this certification journey to be very relevant for me to see how the industry appreciates AI security and as well and the governance aspect to AI security. So who is this exam for? This exam is essentially for people who are solution architects, those that are developers, softwares, and security engineers. This exam is for you, or this journey is for you to experience. And what is inside the exam? So the first thing here is the exam has 17% for AI related cybersecurity, AI, basic AI concepts in cybersecurity, and the exam also covers security of AI systems. That's about 40%, and then AI assisted security 24%, and then AI governance risks and compliance having 19%. So I'm essentially going to be sharing my little knowledge in this domain and also sharing the foundational classes and also the exam prep classes that can help anyone who wants to get the CompTIA security certificate or knowledge. So this is what the CompTIA SecAI exam objective covers. So just like I said, it has those four cadres in 17, 14, 24, and 19% respectively, and it has a very granular coverage of each of the four topics. So, for example, um, uh, for the basic AI concept related to cybersecurity, the course or the certification uh, explains or expects candidates to understand types of AI, model training techniques, and that's this one, and then prompt engineering techniques as well. So these questions, I saw some of these questions in the exam today, not just these ones. I also saw the importance of data security when it comes to AI. All of these questions, some of them like questions that actually lead to another question. And like the situation where you answer question one and then question four snitches the answer. So you find the answer of question one from four. So that's an interesting thing that I saw today as well during the exam. And also, there's another aspect to the course as well, the governance and life cycle aspect of the exam. So the exam also expects candidates to have the knowledge or be able to explain or provide solutions to the importance of security throughout the life cycle of AI. AI is a very hot topic to ignore without talking about security. So we use ChatGPT in workplaces, in medical situations, in transportation systems, in even cybersecurity domains. But the security and the security aspect of the data ingested and the deployment of the model itself, there are so many components that necessitates these CompTIA security exams. So having explained this, I wouldn't just stop here. I would also like to share a few concepts about these basic AI concepts related to cybersecurity. So let's go to the first class. So let's start with the concept of AI. The hottest topic right now is this agentic AI. Everybody's talking about agentic AI. Agentic AI is the biggest umbrella that we have right now. So agentic AI talks about multiple agents, one or two or more agents. Since one agent is not enough to do everything within the domain of cybersecurity, multiple agents can fuse together to proactively decide and execute tasks within the cybersecurity domain autonomously. So this covers the hottest term right now of agentic AI. And then when it comes to artificial intelligence, this is the goal. AI is the broad field and the big goal, right? So AI here is the ability of intelligent systems to mimic human understanding, to mimic human nature, and then and have that intelligence that can learn from data, and then assume the same intelligence or the similar intelligence, related to humans. So AI is the big goal, and many people are confused. What is the difference between AI and machine learning and deep learning and agentic AI? That's why I have this chart. So this chart tries to explain, those distinctions. Even in the exam, those distinctions will be required. You know, so here we have AI, which I have explained, then machine learning. So machine learning is a subset of AI. Machine learning uses algorithms, both nature-inspired algorithms from nature, both traditional classifiers and regressors and other kinds of classifiers to predict the future of based on the input data that is fed. So I will explain more in this video as well. And then we have deep learning. So deep learning is essentially trying to learn deep features from input data and then have a deep layer and then the final output which will help to predict or classify any cybersecurity attacks or any kind of attacks. And then we have natural language processing. Natural language processing essentially learns from or interprets um, data from natural language. So if I said um, the a dog, right? It reads both each character or each letter and then processes it, to solve the main problems. So when we give all these large language models or all these AI algorithms, information, NLP is also involved, and each component you don't need to actually know a lot of this big domain, but you actually need to know the distinction for the exams. And then SecAI here is aimed towards bridging the cybersecurity goals with AI goals. So the intersection of cybersecurity with AI is what SecAI, or what I assume SecAI wants to cover or intends to cover. So like I said, AI is the broad field and the big goal, and machine learning is the subset of AI. What are some types of machine learning? So let's look at some types of machine learning. The first one is supervised machine learning techniques, or supervised machine learning. Supervised machine learning here, even in the exam will be asked, is just like a supervisor, a school supervisor, a class supervisor, a work supervisor. You know, it's already learned from labeled data. So you don't need to do too much. The data is already labeled. For example, medical data. You have cancer images, and there's label it cancer. In malware or cybersecurity core domain, right? If you have like malware samples, they label the data, and that explains supervised techniques. The supervised techniques are machine learning techniques that work or that are integrated with labeled data. The next one is the unsupervised methods. So unsupervised methods use unlabeled data, right? And then the third part is reinforcement techniques or reinforcement learning, right? So we have the supervised, unsupervised and reinforcement learning, right? Unsupervised use unlabeled data, while reinforcement learning uses a reward-based method such that the agent learns from a reward, just like a chicken. If you keep 3 grains of chicken, right, it comes and then you can keep another grain, and then it learns that you always keep this grain at this time of the day, or maybe 7 a.m. every morning, you drop some grains. So it learns that, oh, this guy is about dropping another grain by 7 a.m. tomorrow. And then you see the chicken comes by 7 a.m. every day for the next, or for however long it may live. So that's reinforcement learning. Teaching the model to learn based on reward. Oh, if you do well, I'm gonna give you a good grade. So the reward there is the good grade, right? And the same with any kind of data that is being fed to a machine learning model. What type of model should I choose? So based on this understanding, if your organization is positioned or has the option to use labeled, unlabeled, or reward-based situations, you can now decide and discuss and accept a a model technique based on the data availability that is usually available for the company. In the exam, they also ask about some very important things. Who is responsible? Who is responsible for the data that is fed to the model? So the one that is responsible for the data fed to the model is the data engineer. The data engineer is responsible for pre-processing the data before it gets into the AI or the machine learning model. So that aside, the the data will be processed, and then maybe, for example, we have like some and NAN values, or you have some decimal points you don't need, or you have some images you need to crop out, or you have some noisy data. So the data engineer within the machine learning process, or within the let me write this, MLOPS phase, is responsible, you know, you know, for pre-processing, making sure that the data is clean before it's fed to the model. So what's my organization's goal? Like we already said, and then we can now say that what algorithms are needed. So we can choose our algorithms based on the type of machine learning technique. So here, if it is unsupervised, right? If the data is labeled, no. So you use an unsupervised algorithm. But if the data is labeled, you use a supervised algorithm. So this explains what algorithm may be needed, for what ML algorithm, right? What machine learning algorithm is needed, right? Is based on the nature of the data. So let's go into the core discussion of the SecAI exam, which also tries to talk about MLOps. MLOps. So MLOps is essentially machine learning, development, and the operational systems that follow, or the operational activities that follow the DevOps lifecycle. So is where the ML engineer is integrated, is incorporated, his skills, his relevance, and his experience is integrated into integrating a machine learning or an AI system into an organization. So this is what it is. This explains an ML ops, right? So what are the phases here? We use the first phase, which is the design phase. First, we need to find out the requirements. What are the requirements of the what is the requirement for? Let's pick an example of cancer detection. A healthcare company wants to collect images and then predict cancer or classify cancer images. So we have to find out the requirements of such engineering processes. What is the ML use case, right? And then what is the data that is available? So this is the design phase. So this helps, in actualizing or finalizing the design phase. The next is the model development, because now we have the data. We can now, go into the model development phase. During the model development phase is where I mentioned that the data engineer will make sure that the data is clean before it's fed into the model. And then the ML model engineering involves the choice of model, the choice of the algorithm or the model that you use. So, and then after engineering the model, we go to the next phase, which is called model testing and validation. Before you deploy your model publicly, or before your model is being used, publicly, you have to test. For example, this is what we call overfitting. So the model can perform locally on the data that you've used in your organization or your organization's data. But when you send the model to the public, or when the model has seen a lot of integration and interaction, it now overfits. The model only learned based on your data of the organization, but it did not learn well, for public or general use. So that's why we need this phase, which is called model testing and validation. For the operations, we also have the ML model deployment. When we deploy the model, we have a continuous integration and continuous development CI/CD pipeline that ensures that the model is being adaptable to the current situation or against model drift. So, so in the exam, so model drift is a situation that captures the fact that the model would change its performance over time. So as people use the model would drift, with time. So that's why the CI/CD is very important to handling, model drift situations. And then finally, we have monitoring, triggering, and evals, like evaluating the model that has been deployed. For example, use an AI agent, and a human in the loop is needed. Humans, right, can be needed to ensure that the model's output was actually what was desired. For example, um, I give I build an agent, and this agent is responsible for cancer or medical or spam detection. And then the essence of an eval or monitoring is to observe as a human what came into the model and judge, right? Both you can also judge with another model or another AI system or another LLM, right? And judge if what came in and what was, what was the model's output was what you desire, or what is the desire of the organization or of the deployment. So based on this, I will just highlight a little bit about feature engineering. So data comes with unstructured or structured format. So we have the unstructured images and data here, and then we have the structured format. These are the data sources. So we extract the features, into structured data, and then the feature can be improved, right? For example, if you have images that are not very very clean, or you can optimize or you can enhance the feature, right? And then construct or reconstruct the image, and then extract and select the images that you want, and then have your final data set and then feed into your model. Feature engineering within the MLOps cycle is very very important. And so as well, in the SecAI Plus exam, you would have some questions that try to cover feature engineering. Feature essentially talks about the characteristics of the data that you're putting into the model. So features really really matter. Now that we've talked about the features, we'll talk about some basic methods of basic things such as classification, clustering, and regression. So classification essentially distincts itself from two types or from two classes, right? So you have like a binary class, a class that is either maybe this can be malware. The ones in red might be malware, and then the ones here might be benign or normal samples, right? So a classification task wants to distinguish or distinct itself, you know, from two samples. And then we have the binary class and the multi-class. Binary class talks about just two classes, X and Y class, or Y and X class, or malware or no malware classes, or cancer or no cancer classes. So this is what classification talks about. Some of the classification techniques will require classification algorithms such as logistic regression, support vector machines, k nearest neighbors, decision trees, random forests, and even deep learning algorithms, right? Or deep learning techniques can be used for classification um, goals. So when we classify, we have to check the metrics. How well did the classification um, journey or process do? So we can use accuracy, recall, F1 score. So let me write it down: accuracy, recall, F1 score, precision, and so many other kinds of metrics that can be used, to measure, the performance or the goodness of the classification algorithm. And then we have examples like I mentioned in cancer, right? In cancer detection, we have examples such as spam detection, network traffic classification. For example, you might have a network traffic of denial of service attacks from normal network traffic, right? And then you can measure how well the model did within classification tasks. So we have clustering. Clustering is also another machine learning technique that distinguishes itself from two or more classes. So here we see that the clustering algorithm separates within three classes, and we use another of each separate clustering um, um, uh, algorithm to distinguish between each class. And then we have regression. So regression essentially, predicts itself, sorry, predicts the future. Think about predicting the future, and then think about regression. So regression uses continuous value, right? Just like a stock market. Think of a stock market, right? You want to predict what would be, the price of gold in the next 2 hours, right? So that's a regression task. In a network security domain, you want to predict based on the last hour of network traffic that has come in, what would be the nature of the network in the next 1 hour. So this is the goal of regression. And we can now easily go into that exam or go into the SecAI plus exam with understanding the difference between regression and clustering and classification. So let's use case studies. So this case study was one from my publication during my master's degree, where we use an explainable AI technique for network traffic classification. So I'll walk you through the whole pipeline. We assume that an attacker will want to compromise the network, and then it will have maybe an attack network traffic, and also we can have a VR campus, right? Maybe students using VR network, right? One, two, three, and then we can have a combination or a clean or unstructured combination of normal, which is this one, versus abnormal traffic fed into the network. And then when we have the network, right, this is before deployment. We preprocess the features, right, of the network. After doing that, we use a model based on the kind of data that we have here. In this kind of data, we had a label data, right? And then I'll show at the end of the video example of a situation where we use a label network traffic data for classification. So we use a label data, with an equal or accompanying model, right? So here we use a deep neural network, right? And then we can classify the model decision whether the network traffic, right, or an incoming network traffic is an anomaly or a benign network. After the model's decision, right, there's what we call XAI. XAI means explainable AI. Explainable AI essentially uses quantitative and qualitative um, techniques to interpret the decision of the model. So we want to know how or why should we trust the model's decision. So explainable AI provides confidence and reliability into or for a model's prediction or how well a model predicted. So that's why we have like XAI here, to judge the to judge the model's decision or the model's classification. I hope that this is clear with this brief case study. So this case study, envelopes or tries to explain, each component of a typical use of AI for cybersecurity or ML for cybersecurity. In the coming videos that I will be sharing, we'll also look at how AI can be used for offensive security because it's also a fundamental component of the SecAI Plus exam. Before we wrap this side, we'll also talk about the anatomy of a deep learning model. I was actually surprised for them to ask this question, because we'd be expecting like maybe fundamental questions about security AI, but one of the questions that can come up would be, the input layer of the model, right? During the course of my study, I saw some of these questions, right? I saw some questions, online and YouTube resources that asks, what is the input code, right? Or what is the after the input, what do we see next of a deep learning model? This anatomy is very important, to understand or to ace the SecAI Plus exam. And so let me just explain what is going on here. So we have inputs. A network traffic, for example, a malware will have inputs, and each sample, right, will have its own weight, W1, W2, Wn. So these weights are fed into, are combined with a bias, right? This is the weight plus bias, right? Is fed into the activation layer. We have the input layer, this is the hidden layer, and then we have the output layer, right? The input layer, the hidden layer, and then the output layer. That's why deep learning models are kind of referred to as black boxes in some time. So we have the input, the weights, the bias, the activation, and then the output. So this is the anatomy of a deep learning model that can come up as well in the exam. Um, Finally, we'll talk about generative AI versus predictive AI versus agentic AI. So generative AI talks about, can you create something? Generative AI in the domain of offensive security might want to, can you create a malware? Can you generate a polymorphic malware? A malware that adapts to, any kind of changes or any kind of defense methods. So that's what a generative AI will do to generate, right? And then an agentic AI, can agents proactively handle, you know, a task without without supervision. So can agents execute, think, and plan acts or plan cybersecurity tasks, by themselves and autonomously? So this is the goal of agentic AI. And predictive AI talks about what likely is to happen, what will happen in the next hour of the network, you know. So based on this, we can think of use cases that fit the nature of predictive, generative, and agentic AI. I know that this summary might not be complete for the first part of the course, but it gives us an understanding of what is needed, right? We need to essentially understand the fundamentals of AI. If you're into research, it might be very, very much easier for you if you're into AI research per se. But if you're not, this is like the fundamentals that will help you or that will help anyone, to try and, understand what is going on when it comes to AI, Sec AI plus. Finally, let's look at a typical example of network traffic classification using a neural network. So this is like a public GitHub repository. You know, Here is where we import the libraries used for the training. Pandas and all of those libraries, right? And then we have the dataset. So this dataset comprises of network traffic features. So we see feeds underscore importance are the traffic features of the network itself. And then we now have, the target class, what we want to target, right? And then I'll just go over to the model definition itself. This is where they load the model. This is the model that they use, right? And then we can see that when the model is fitted, they use the cross entropy, they use the Adam optimizer, and their metrics is the accuracy. And then we can see the number of epochs that is trained. Epochs means how long or what is the train time, sorry, how long was the model run, for before final deployment. So it was trained for, 10 epochs. These kind of questions also show up in the exam. And then we have to measure the model's performance based on accuracy, precision, recall, and F1 score. So this is an example of how AI and network traffic, can be used for security. So I've covered like the basics of the excuse me of the chapter one. I can also in my next video, I'll also try to explain more concepts within, this domain of AI related cybersecurity. So here we talked about generative AI. Excuse me. Yeah, generative AI. We talked about Gen AI. We talked about machine learning. We talked about deep learning. We didn't talk about transformers. We'll come back to this. We also didn't talk about this. We didn't talk about large language models and small language models. We didn't talk about these ones, right? They will be the focus for our next class. But we talked about model validation, supervised learning, unsupervised learning, reinforcement learning, right? And then I forgot to mention fine tuning, but this fine tuning method comes with its own batch. So I will talk about fine tuning and NLP in my next video, and also talk about prompt engineering to cover the basic AI concept related to cybersecurity. Thank you for watching, and if you have any questions about the SecAI exams, please feel free to reach out or leave a comment. Thank you.